So next model is gradual replacement. In the previous section, we have in the model 1 we have seen that whenever we want some new items, I just call up my friend and readily he send instantaneously. But over the period he became very famous. So many people are requesting him to send these items, and he is not denying anything, but he is sending gradually. Instead of sending immediately, he is sending in a gradual continuous way. So here there are 2 points that we need to note down. 2 points, those are, first one is the supplier continuously replenishing that, okay, continuously. Replenishing. That means this is a production rate or a procurement rate. Both are actually anonymous. Whatever we are procuring is producing that and sending to us. Okay, so production rate. This is a production rate. Let's say this is a capital P. Okay, this is continuously sending to us, and at the same time we have a consumption rate also. Consumption rate. This is a consumption rate. Let's say this is a capital C. Okay, so at the same time we are consuming. For example, I ordered, I need urgently 10 tires. Okay, today I need urgently 10 tires, but because of his inability, he promised me to supply only 2 tires a day. Okay, he is sending 2 tires per day, and he also promised me that he will supply all these 2 tires within 5 days. Okay, so let's say the time period is TP. Why? Because it's a production time or procurement time. So I need 10 tires and he is instead sending only 2 tires a day, and he is continuously sending for 5 days. Okay, then Q equal to, can I say that P into TP? Okay, that means 2 tires a day for 5 days will become 10 tires. Okay, that is what this relation is. This is an important relation, you please remember this. Okay, and now what I do is, instead of this, here production is 2, and at the same time in my plant I am using 1 tire per day, okay, for the new car. So here I added up one more thing. So C, consumption rate equal to 1 tire per day. Okay, then what happens? So first day, this is the days. Okay, first day, how many tires used? First day 2 tires he supplied, but I used 1 tire, and the second day he supplied 2 tires, again I used 1. Third day he supplied 1 more tire, 2 tires, and again I used, and the 4th day and the 5th day same situation. Okay, tires, this is a with consumption. When C is there, this is the scenario. Okay, without C, so if there is no consumption means, see, if there is no consumption, why the hell we order first of all the tires? There is a consumption, but the consumption is not there until we procure all 10 tires. Okay, so in the first day, if there is no consumption in the first day, 2 tires, and second day 2 tires, third day 2, and then 2. Okay, and at the end of 5th day, what is the balance here? Okay, if I calculate the balance at the end of 5th day, then here with the consumption we have only 5 tires, and without consumption we have 10 tires. Okay, this is a with consumption, and then this is a without consumption. Okay, so this is nothing but, without consumption is nothing but the previous model. Okay, see what is the difference, what is the meaning. Okay, this is a gradual replacement, and at the same time we have a consumption also. See, for example, if there is a no gradual replacement, or I mean if we have a gradual replacement at the same time, if there is no consumption, that means we are reaching the point Q, 10 tires, we are reaching the 10 tires. In the previous case also we are reaching the 10 tires. After that only consumption started in the previous case, and here also after that only consumption started this. So the last column is nothing but the previous case only. This is equivalent to the model 1, equivalent to model 1. Okay, but here in this one second model we have a consumption rate also. Okay, so we will see how to draw the graph in this case, or how to represent diagrammatically the. Okay, we will keep this, and here this is the y-axis, this is the x-axis, and on the y-axis we represent a Q, number of quantities that we are procuring, and this is the time axis. Okay, so here in this case, for example, I want to procure 10 tires. Okay, and this is the production or procurement rate. This is a procurement rate P. So how many days we procured like that? Up to 5 days. Okay, so this is nothing but 2 tires per day. So for 2 days he is continuously sending, every day he is sending 2 tires. That's why this is a straight line. Okay, uniform. So yet 5 days, after 5 days we have a 10, we reach 10 at the rate of 2 tires per day. Okay, we reach like this. That is nothing but the first case, and if you start consumption now, then it will go like this. Okay, this is a C equal to 1 per day. But instead of that, here what is happening, we have consumption also at the same time. Okay, so we have consumption, this is nothing but P minus C, and here always remember that P greater than C. Okay, why? Because if the procurement rate is not greater than C, then there is a shortage. Okay, so even before the item reaches warehouse, it will immediately send to the plant. Okay, then there is no time it is spending in the inventory. If it is not spending in the inventory, what is the use of calculating all this? We are trying to find out the number of quantities that we need to order, so that the total cost should be less with respect to the inventory expenditure. Okay, that is our whole idea. And if this C is greater than P, then there won't be any items staying in the inventory. Then to stay those items in the inventory, here P should be greater than C. Okay, so here instead of 2, then it is becoming P minus C is becoming only 1, and if it is only 1, at the end of 5th day, this is the 5 days, this is the days. Okay, at the end of 5 days, how many quantities are there? Only 5. Okay, so this is the 5 items at the end of 5th day. Okay, according to the second row, and here we need to connect this. Okay, and what is this? This is nothing but P minus C. This is P minus C, and the previous is P, and P1, my P minus C is nothing but 1 here in this particular example. And now onwards we don't have P but only consumption. Okay, this is the consumption, that equal to 1 tire per day. Okay, and it's reaching the rock bottom, 0. Okay, like that the cycle will repeat. Okay, so here what is the 5? 5 is nothing but a Q1, and Q is a maximum on hold inventory. This is the maximum value that is there. You forget about this. This is the first case, and in the second case only red color one is there. Okay, at any given point, what is the maximum inventory that is having in the warehouse? That is only 5. That is nothing but a Q1. Okay, we need to find out the Q1. Because we don't know what is the q1, we need to find out q1 in terms of q. Known values are q, p, minus and c. We need to find out that. Okay, we already know q equal to p into time period. Let's say this time period is a tp up to this point. Let's say this is O, this is A, and this is a B. Okay, so this is a TP, procurement time. Okay, that we have already seen. In the same way, Q1, this one, is related to this line. Okay, that is a P minus C for the same time period. That is a TP. Okay. And if I substitute Tp from this equation in the second equation, then it will become Q1 equal to P minus C into Q divided by P. Then it will become Q1 equal to Q into 1 minus C by P. Okay, this is the equation second equation. We need to remember this. Okay, now what is our next step? We need to find out the optimum value for the TC, total cost, and while calculating that, our main area of concern is the total cost, how it is affected due to the inventory expenditure. So TC, I am neglecting the Q into C. Okay, this is not going, it is not having any effect because of the inventory. Okay, so here ordering cost into number of orders n plus carrying cost into what is the average inventory there, average inventory. Okay, why we take average inventory? For example, this is the warehouse. Okay, on the fifth day, how many are on the first day, how many items are there? On the first day, this is the 0th day. On the first day, this is the first, this is the second, this is the third, and this is the fourth. How many items are there on first day? One item. Why? Because 2 supplied and 1 consumed, so 1 item is there on the first day. And second day, 2 items are there. Third day, 3 items. Fourth day, 4 items. Fifth day, 5 items. Okay, this is increasing. And what is the maximum? And again it is decreasing. Again 4, 3, 2, 1, and then becoming 0. Okay, so we need to take to calculate the every day the amount of items or number of items there in the warehouse are changing, and we need to calculate the Q, so that if you multiply with the CC, then we will get the holding cost. So if it is changing linearly, then we need to take the average. What is the maximum one and the least one? Here least is 0, maximum is 5. Okay, the 5 is nothing but Q1 here. Okay, whatever this line maximum is corresponding to touching this line touching on the y-axis is a maximum on hold inventory. Okay, so we need to take average of that in this particular case. So what is that? That is a Q1 divided by 2, Q1 max plus 0 divided by 2. And here C0 into, here n is not Q1, sorry, n is a D by Q, not Q1. Why? Because here we are ordering 10, not 5. Okay, always, for example, I need 10,000 tires and we are ordering 500 each time. But since these 500, how they are coming and all, I don't mind, but I just ordered 500 in the previous case also. Here also I am ordering 500, but this entire 500 is not coming at the one time. They are coming slowly. Okay, and then here CC into Q by 2 into 1 minus C by P. Okay, and if I differentiate this with respect to Q and equate to 0, then it will become minus C0 D divided by Q square plus CC divided by 2 into 1 minus C minus P. Okay, then Q equal to 2D C CO into CC into 1 minus C by P. This is the square root. Okay, now we will see different formulas in this, and what is the total cost, minimum total cost. If I substitute in this equation, we will substitute Q star in this equation, we will substitute, then it will become C naught D in Q star is a, okay, directly substitute, and finally we will get 2D C naught Cc into 1 minus C by P, okay, and then number of orders in a year or in a particular time period, that is nothing but D by Q star, that equal to dCc into 1 minus C by P divided by 2C order. And here TP, procurement time. So I want to find out the procurement time, that equal to Q star divided by P. Okay, this is a basic formula that we used in the starting. Then if I substitute these, then we will get 2D C naught divided by Cc into 1 minus C by P. Okay, so there are so many formulas, don't get afraid of this. Okay, so these formulas I will tell how to remember this. If you remember the formulas in the first model, then it is very easy. So everything is same except this particular value. What is that? That is 1 minus C by P. Okay, and here don't get confused between the C by P and P by C. Okay, what is the value of C by P? That is less than 1. And what is the value of P by C? That is greater than 1. Why? Because P is greater than C. And if you write P by C instead of C by P, then this value become negative, and here the square root become not defined. So in that way you can always remember this. And there is one more thing that you need to remember, that this Cc and C naught. So sometimes you may get confused that the 1 minus C by P is followed with the Cc or C naught. Okay, that is also one doubt. Here ordering cost is nowhere affecting because of the whatever amount of quantity is there in the inventory. Okay, what is the meaning of that? For example, if there is no consumption, if there is no, see here we are ordering Q. In the model 1 and model 2 we are ordering Q only. So when in the model 1 when we ordered Q, what is the maximum hold in the inventory? That is a Q divided by 2. But in the case 2, model 2, this is a Q1 divided by 2, because Q1 equal to 5. Okay, this is the first model where the maximum on hold inventory is a Q and the average is a Q by 2. And whereas this one, in the second case, the maximum on hold inventory is Q1 and the average value is Q1 plus 0 divided by 2. Okay, here in this case this is a 10 by 2 equal to 5, and here in this case 5 by 2 equal to 2.5. Okay, that means the number of items that are there in the warehouse are reducing in the model 2. Okay, when the number of items in the warehouse are reducing, then which cost will be affected? Of course, carrying cost. Why? Because the carrying cost is, the definition is like that. Okay, but here if you observe, the number of items that we ordered are both in the same case. Okay, in the model 1 also we ordered 10, and in the model 2 also we ordered 10, but the number of items in the inventory or warehouse is reducing. Okay, but Q is not reducing here. That means C naught is not affecting. C naught is constant in the both cases, but only the carrying cost is affecting. So my dear friends, in the previous model 1, wherever you have the formula, just replace Cc with Cc into 1 minus C by P. Okay, so by replacing with this you will get the model 2 here. Okay, then we will see some of the examples.
For engineering services general studies video lectures, visit www.iesgeneralstudies.com. For mechanical engineering video lectures and question and answer discussion, visit www.getnet.com.